Hello, my name is Arturo Aguirre,
And my name is Marta Wensler.
and we're both chemists here at Regis Technologies. And part of Regis Technologies is our continuous improvement projects, and one of them is Quantitative NMR. And we'd like to show you our findings within.
Quantitative NMR has many advantages over traditional methods for determination of purity and potency. Particularly, signals are directly proportional to the number of corresponding nuclei and are not susceptible to differences in chemical characteristics like absorptivity differences or differences in ionization efficiencies. Additionally, it has a broad chemical compatibility compared to traditional methods, and the fast signal acquisition and data production means fast method development and data turnaround time.
qNMR is also being accepted by the International Conference of Harmonization, and if you know, traditional analytical methods run through the ICH as well. Specifically, Q2 and Q14, which deal with purity and potency, are being revised and are going to be endorsed in May of 2020. This will include a validation procedure, which is very important for determining purity and potency. This is great that qNMR is already being considered through International Conference of Harmonization. Regis is going to offer a qNMR for multiple stages of development, so testing of our raw materials, process development support, our reference standard qualification, and even final testing.
So our general procedure for quantitative NMR is a collaborative effort between the analytical and process chemistry teams in terms of selection of internal standard. We would like our internal standards obviously to be compatible with our sample of interest chemically, both soluble in the same solvent and both display stability in that mixture. So our highly trained team will use our high precision weighing systems to weigh accurate mass samples, prepare those for our in-house NMR analysis, and with that data we can see this example Spectra using TCNB, tetrachloronitrobenzene, and caffeine as an example. These signals are well resolved, and getting those integral values, we can plug them into our purity calculation to get accurate purity of our analyte of interest.
And not only do we want to calculate purity and potency, we also want to calculate the statistics behind the purity and potency. So as many analytical method development chemists know, we don't just calculate a purity, we calculate the specificity, we calculate linearity, we calculate instrument method precision, accuracy, and many other parameters. But here's a great snapshot of what we did in-house to assess our method, our qNMR method. Here we have a sample of 4-iodoanisole at a target concentration of 20 mg per mil, and our internal standard TCNB, tetrachloronitrobenzene, at 10 mg per mil. And one part of specificity is just running a qNMR experiment on the diluent of your sample preparation, so the deuterated solvent, and whether it has any significant interferences with your sample or internal standard. Looking at this example Spectra, we do not have any interferences between that. We use chloroform here. Chloroform comes out around 7.2 ppm, so we don't really have any interference between that, the sample and the internal standard. Another facet of specificity is whether there is resolution between internal standard and the sample itself. We actually see that there's multiple peaks of resolution between the sample and the internal standard. So you can see this methoxy peak is upfield of the internal standard here at about 7.7, and these aromatic peaks are still upfield of that internal standard. So we can use both of these peaks to assess the different key assessment parameters that we typically do in analytical. Linearity is also a very important key performance aspect of qNMR and traditional methods. Here you can see we obtained an excellent correlation coefficient from a range of 10% to 120% of our target assay concentration. The method precision was performed by doing 5 experiments of 1 sample preparation to determine if our method has precision within a criterion of about no more than 2.0%. As you can see here, our performance criterion was absolutely met, and it was sub 1%, which is great precision. We also determined accuracy at different levels, our 100%, our 80%, and 120% level. We can choose multiple levels and determine different criteria. Here we're choosing a 95 to 105% recovery of the integration that we received at each signal at 3.8 and 7.59. And as you can see here, all of them are in the range of 95 to 105%. These ranges can definitely, the ranges for method precision and accuracy can be adjusted for validatable procedures and also just typical method procedures. And then, so now we can calculate what we really want to see, is the purity and potency of our 4-iota NSL. So in the chemical shift of 3.8, using that methoxy resonance signal, we calculated a purity/potency of 92.06%, and then those aromatic hydrogens, we calculated a purity of 91.94%. So can we use either one of these purities/potencies interchangeably? Is one better than the other? There's a way to actually analyze that, and one way to do it is through an analysis of variance, or an ANOVA. So we've actually calculated this and determined that they're not statistically different. So we can use either chemical shift, and it can be used for purity and potency.
And an example of our use of this tool in-house, we had a single lot of API that was analyzed by our traditional testing techniques, assayed by HPLC, Carl Fisher, residual solvents, etc., to calculate a purity potency value of 98.9%. Using our orthogonal qNMR method, we calculated a value of 99.1%. And this shows that we can rely on qNMR, a much faster technique that doesn't require a reference standard of our API for calculation. So how does qNMR support development here at Regis? That is a standalone method that does not require a combination of other analytical techniques, Carl Fisher, residual solvents. It's fast and accurate. It does not require a standard of the API or sample in question for calculating purity potency. And it can also be used as a tool to solve any discrepancies that we're seeing in our values.
Yeah, and also like we were stating earlier, it's rapid method development. You don't need to do an HPLC, a Carl Fisher, residual solvents, and combine all these data together to determine a purity and potency. We can use one method, it's qNMR. So in one day we can report a purity and potency. Again, leading to fast data reporting. Also the method can be validated, so we can get those tighter criteria and have really confident purity and potency values.
So Regis has developed this technology to offer to our customers to fulfill a broad type of needs as an orthogonal purity determination method for confirmation and testing, and also moving through development. And we have a highly skilled team here with a lot of experience at NMR and quantitative NMR.
Yeah, absolutely. Yeah, so thank you for tuning in to the qNMR presentation that Marta and I have been working on. And Marta does NMR a lot, all the time, so it's like, it makes sense to use qNMR as another tool in our wheelhouse. And yeah, feel free to email either of us for any questions you have. Marta's a really nice person.
And Arturo's a really nice person.
So yeah, we're really just trying to offer you other methods that are not just traditional. We want to be in the forefront of technology, especially because NMR is an excellent tool here. So.